So for this trigonometric identity, the more complicated side, it's kind of hard to tell because both the left-hand side here and the right-hand side here, I mean, I guess you could say they're equally complicated because they both have, they both have a tan, they both have a sine squared, and I don't know, it's kind of a shot in the dark which one would be the best one to work with. Once again, we're going to be referring to our, basic trig identities that we know that we can use. And remember, you can always use ones that you've proven before, but to keep things simple, I'm just going to rely on, this basic list here. So where to start? You know what? I'm just going to take a shot in the dark and start with the left-hand side. I kind of see a pattern emerging here, or not a pattern, but a way through to get to the right-hand side. And I don't know, let's see if it works. Okay, I'll show you my idea as I go along. So let's start with the left side, and that's equal to tan squared x minus sine squared x. And what I'm going to do is I'm going to pull a substitution here. I'm going to replace the tan x up here with the trig ratio for tan. So because it's squared, I'm going to square the numerator and the denominator to give me sine squared x all over cos squared x. And in the same step, because sine squared is a fraction over 1, I'm going to multiply it by cos squared x. And the reason for that, again, I'm looking ahead, is that I want to combine it with the fraction that I already have over here, and the denominator is cos x. So I have cos squared x over here. And now I can combine them together. Okay, so what do I get? I'm going to get sine squared x minus, to save myself some writing, I'm just going to copy this over here. Oops. I'm going to copy all this guy here. One more time. See if it works. Copy and paste. Beautiful. And I'm going to write that all over cos squared x. Okay. Now, I think we are making some progress because I can see that these two terms, the numerator, they both have a sine squared x, and that's what I want to get on the right-hand side. So I'm looking ahead. I'm noticing that, hey, they both have a sine squared x. Let me factor that out because I'll end up with a product, which is exactly what I want. So I have sine squared x, and then in bracket, 1 minus cos squared x. I'm going to close that and write it all over cos squared x. This is looking promising a lot more now, because if you notice here, sine squared and cos squared is again my tan, so I can write that as sine squared x over cos squared x times 1 minus cos squared x. And that, of course, is over 1, just to be, I guess, more complete. I'm basically, separating the fractions into two, the product of two fractions. And here we're going to have to use a modification of the Pythagorean identity, because remember, that's actually 3 identities in one. We have this one here, but also if we bring the sine squared over to the other side, this is also the same as cos squared x equals 1 minus sine squared x. Actually, yeah, it is, and it's also sine squared x is equal to 1 minus cos squared x, which is the one, sorry, that I wanted to use over in here. So I'm left with, well, sine squared over cos squared, that's going to give me tan squared x times 1 minus cos, well, that's the same as sine squared x, so times sine squared x, and lo and behold, well, whatever, just to make sure it matches completely with what I have on the other side. in my question. I'm just going to commute the terms, the factors, and that's equal to the right side. And that completes our proof once again.